Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's dive into today's daily challenge on Leetcode and see what is there. So we need to find the closest node given two nodes. We are given a directed graph of n nodes numbered from 0 to n minus 1. Each node has at most one outgoing edge. The graph is represented by an edges where edge I represents the node to which the node I is connected. If node I is connected to edges of I, then it is given by the edges array. And if edges of I is minus 1, it means that that is the ending node. There is no more path from that node. And you are also given two nodes, node 1 and node 2. You need to return the index of the node that can be reached from both node 1 and node 2 such that the maximum distance from node 1 to that node and from node 2 is minimized. And if there are multiple possible answers, we need to return the one with the smallest index. So it may also contain cycles. You need to note this. So if you see in this example, edges are 2, 2, 3, minus 1. So what does this mean? So first index 0 has a direct edge to 2. That's why here it is 2 written. The second index 1 has a direct edge to 2. That is why again there it is 2. The third index 2 has a direct edge to 3. So that's why it is 3. And there is no more outgoing edges from 3. So that's why the last one is minus 1. Okay. And node given two nodes are 0 and 1. So yeah, that's how what the problem description says. And now let us try to see the approach. Okay. So let's start. So we are given two nodes, right? So one thing you can understand that from every node, there can exist at max one outgoing node. Okay. There cannot exist a node which has two outgoing nodes or three outgoing nodes like this. There cannot exist a node. So the node will be in a single path. Do you understand this thing? There can be things like multiple incoming nodes, but the outgoing nodes can be at most one. So for example, this is a possible graph, which is very much possible. Okay. So this can be a possible graph type of thing. So what you are given two nodes. Okay. You are given two nodes, node 1 and node 2. These are starting nodes. Okay. So you do understand that if you start to traverse node 1, you have only one choice to traverse in node 1 because there is only one outgoing edge or there is no edge. Okay. You have only one choices. Similarly, from there you will have another choice and so on. So from node 1, that's true for node 2 also. So from node 1, you have one path. Okay, you have one path. From node 2, you also have another path. Now, if you see, if by chance these two paths connect somewhere at some node ND, these two paths through various other nodes, if these two paths connect at a particular node, then that particular node also has one outgoing edge. So that will also be one outgoing edge, right? So we need to return the maximum, what it is told, the maximum distance among these two nodes. So let's say the maximum distance from this is 3 and the distance from this is 5. So maximum among these two is max of 3, 5, which is 5. And we need to minimize this whole value of 5. Okay. Like we need to check if it can also contain a cycle, right? So we need to check what are the possible values. So what can be the approach? If you think of the approach, if you try to think, you can make two arrays, distance 1. You need to take care of the distance, right? You need to minimize the distance. You can make two arrays, distance 1 and distance 2. Okay. You can initialize the arrays by -1. Okay. All elements of the array, this should have length n and it should be initialized with -1. So it will also help us to track whether the node is visited or not. And this in turn will help to detect a cycle also. So distance 1 will have all the nodes, will have distance of node 1 from all the nodes. Okay. Distance of all nodes from all the nodes. So if node 1 is there somewhere in the middle, so distance will be 0 from here. Similarly, distance 2 will have distance of node 2 from all the nodes. And if some node is not reachable from node 2, the distance will be -1 because it is -1, right? So what we can do, we can simply track the distance. We can start a DFS from node 1, uh, keep tracking all the distances by doing d plus plus at every step and marking d distance of 1 of I equal to d. Yeah, and similarly we can after filling these two distances array, we will just iterate through all the nodes. We will see that if distance 1 of I, if we are at the ith node, that is not equal to -1. So it means that it is visited in the path from node 1. So if you can understand, right, from node 1, there will be only a single path. There cannot be multiple divergences like this because no node has two outgoing edges. Node 2 also I am marking out this path only. Okay, so if the distance from I is visited by node 1 path and it is also visited by node 2's path, okay, then we need to find the maximum distance among these and we need to minimize that. We can have a minimum global variable and we need to minimize this. So that is all we need to do. So let's try to solve it together. We have n nodes is given by the size of edges, as you know it. And so what else do we have? So yeah, we have distances array. We need to initialize those. So vector int distance 1 is there, which is initialized by -1. Distance 2 is there, which is initialized by -1 again. We need to fill this using the edges and node 1. You need to fill distance 1 and using edges starting from node 2, you need to fill distance 2. Okay. Now what will be this DFS? This will be definitely a void DFS, which takes vector int edges, int node, right? This bit short. And what else it will have? We also need to populate this distance vector, right? We need to populate this distance vector. Okay. So definitely first we have a d variable which is initialized to 0. Okay. So you see at the end of every node, as we go from, let's say we are going from this node to this node to this node, if there is no more nodes, there is -1, right? It is told that in the edges array it is -1. So we are at current node, let's say cur. If we are at the current node cur, so unless cur is -1, we will keep iterating. You can understand this, right? Not cur. I will update the node value only. Okay. Unless, and let's try to do this first. Unless this is not -1, we keep updating the node, right? We keep updating the node. We go to see that what is the neighbor node of edges of neighbor, and then we update it. We do d plus plus also. But one thing you need to take care that there may be a cycle also, right? So what if there is no -1? What if there is no -1, but there is a cycle like this? So you will keep iterating on it forever. So you need to know that there is a visited array, and here visited array is represented by this -1 only. So we need to take care of that also while breaking this. So we just take care of that. Distance of node should not be is equal to -1. Only if it is not visited, that is if it is -1, then only I will update it. Okay. And initially the distance from node will be d. Then we will update it and then so on. Okay. So this is understood. Now it is simple. We have the distances, the array, which is already fully populated. We just need to iterate and check in these conditions. So we need to iterate from, let's say, all the nodes. I'm going through all the nodes and checking that if node I is not -1, means that it is visited by the path from node 1. If node I is visited by the path from node 2 also, that it is not -1 also, then you need to further calculate, then proceed further. So what you need to do, you need to calculate the max value. Max value is nothing but the max of this distance 1i, distance 2i, right? You need to minimize this maximum value. So definitely you will keep a answer here which stores the index. You need to return the index of the node that can be reached. Remember it, not the distance. So you have also the index. Let's keep it at index. And you have the minimum value. You need to minimize the value. What is the maximum value? Here it is written 1 is 5. So let's take it to be 1 is 6. Let's initialize it to be 1 is 6. And now we do the simple minimum thing. If value should be minimized, if value is greater than, if minimum is greater than the value, okay, so then value is minimum, right? So minimum equal to value, and for that index is I. Okay, yeah, this is done, and all you need to do is return index. So yeah, that was all, I guess. Let's try to submit it and check if it works. So there is some error, technical error. Let's try to see the solution. Let's try to see the approach. Okay, the index, it is told that if you cannot do anything, if you cannot find any path, then return -1. So initialize it with -1, then only it would work, right? Yeah, so we do have the accepted. Let's try to submit it. Yeah, we do have the accepted thing. I think this was really simple. You just mark the path from both the nodes and you see that which nodes which are visited by both, out of all the nodes which are visited by both, which one we can take the maximum value and we minimize that maximum value. Okay, we minimize that maximum value and save the index. We need to return the index, so we just save the index. So that was all for this problem. We do have a okay runtime complexity also. So yeah, that was all. This was definitely a medium problem, and I hope your day is going to be really easy. Thank you so much.